show you how to basically do hypothesis testing on the Ti-84. So this first one, I took these from the assignments from this semester, which were from my open math, but at the end of the day, you know, everything is basically the same. So you have the null hypothesis, alternative hypothesis given. You have a sample of 30 values. You're given a sample mean, and then you're given a population standard deviation. So we're going to basically use what we call z-test on the graphing calculator. So you know that, you know, if you were going through the process, you use these scores and all that kind of stuff and to find the test statistic. Now the graphing calculator is going to give you the p-value and the test statistic. You know, when I go through the process and I find, I go through this process, what do you call it, z-test. Z-test, all the stuff in the graphing calculator that ends in test deals with hypothesis testing, but it's not going to give you critical values. It's going to give you the test statistic and the p-value. So, all right, so we find it in stat, and we scroll over to test, same way that we did with confidence intervals, and all the stuff is up here, all the stuff that ends in test. So obviously use z-test when sigma's known, and t-test when sigma's unknown, and then the rest of the stuff is here as well. But we're going to do z-test for this example. And again, you see that you have data and stats just like you did when you did confidence intervals. So you would use data if, you know, if you had a list of values, which we don't for this case. We're actually given the statistical values. So I'm going to scroll over with my right arrow and highlight stats. And then hopefully we know what to input here. So this is basically what's on the null, what the claimed value, what are we dealing with. So in this particular case, 52.1. And then sigma was given 2.22. X bar was given 52.6 for this example. And then n was 30. And then down here, we tell it what kind of test. And obviously these are the alternative hypothesis. So in this case, it's right-tailed. So I'm going to scroll over and I'm going to highlight that one. So this is saying that mu is greater than the claimed value, right? Which is what our alternative hypothesis is telling us. It doesn't really matter what color, you don't need to draw it unless you want to see it, but I'm just going to calculate to get the values and then enter. And this is my output. I use z-test. The first thing that I see is my alternative hypothesis, okay? So it should match the alternative. The next thing that I see is my test statistic. So this gives me the test statistic. The next thing that I see is the p-value. It gives me the p-value, and you guys know whether you use a p-value to reject or fail to reject and all that stuff. And it gives me the sample mean and the sample size if I want that. So again, alternative hypothesis, test statistic, p-value. And that's the order for all of these when we do the hypothesis testing, z-test, t-test, whatever. It's always alternative hypothesis, test statistic, p-value, and whatever statistical values correspond to that situation. So this is how we find, so z-test is going to give us the test statistic and the p-value. You know, when you're dealing with the critical value, obviously that's, you know, in this case a z-score, you'd have to go second bar. So you're going to go back to inverse norm if you're doing your critical value for this case. And then you could just refer back to that video when you're finding z-scores from known area on a curve. So obviously this is a right tail test, you know, alpha would be the area in the right tail, and then you would go, you know, and find your critical value with inverse norm because it's a z-score. Give it the area. Not everybody has this option. It depends if they do or don't, and then, you know, put everything in here. So that is the first hypothesis test, how to find those little values that you need to basically run the test when you have a hypothesis test regarding a mean and you know your standard deviation for the population, sigma. You go to z-test. Again, z-test gives you the test statistic and the p-value, not the critical value. You do have to use inverse norm again for your critical value, just like we did, you know, back in whatever week it was when we dealt with normal CDF and inverse norm.